Hello, this is Tom, and in the last video I showed you how to write a G76 can cycle for a 1/2 inch 20 thread for the CNC lathe. In this video I want to show you how to use that same G76 can cycle to run a metric thread. We're going to have to do some conversions, and I'll show you how the call out of the thread is different from a metric to an inch. So let's take a look at those numbers and let me show you how that's done.
Alright, so the first thing I want to go over is how a unified coarse thread, or a UNC thread, is called out. We refer to that as a 1/2 inch 20 thread. And that means that for every inch there are 20 threads. So if we divide that inch by 20, we get 50 thousandths. Now that is used in our G76 can cycle as a feed rate, which in turn produces the lead of the thread. So let's see how that's different in a metric thread. Alright, so here we're looking at the standard metric thread call out, and for this example I have picked the M12 by 1.75 thread. Now the M12 right here stands for the 12 millimeter diameter of the OD of the thread. And then the 1.75 is the lead of the thread, so there's 1.75 millimeters between threads. So if we do a little conversion, we take the 12 millimeters and we divide that by 25.4, then we come up with 0.4724. So that's what we're going to use in our G76 program as the major OD. Then we're going to take the 1.75 and divide it by 25.4, and then we'll come up with 0.06889. So I'm going to round that off to 0.0689. So that number is going to be used in our G76 can cycle as our feed rate, which in turn produces the lead of the thread. So let's take a look at our G76 can cycle, plug in these numbers, and get it ready to run a metric thread. Alright, so here we're looking at our G76 can cycle for an M12 by 1.75 metric thread. Alright, we're going to start off with a tool change to tool number 9, and then we're going to turn the spindle on to 1000 RPM in a clockwise direction. Then we wrap it to G54 X.6724. Now that's 200 thousandths more than the OD of the diameter of the thread. So that's 100 thousandths above the thread in X. Then we're going to wrap it to Z.2. That's 200 thousandths in front of the part, which is enough distance for the Z-axis and the spindle RPM to perfectly synchronize every time it takes a pass. Alright, so the first G76 line, the P03. The 03 right here is the amount of spring passes that it takes at the bottom of the thread. So obviously if you put a 0 there, you won't get any spring passes. The second set of digits is the angle that the tool will pull out of the thread at the end of the thread. When it comes to that Z minus 1 inch 2, when this is 0, it pulls straight out of the thread. Now, if you put a 2 in there, then it takes the lead of the thread, which is determined right here by the feed rate. So if you do 2 times 0.0689, then that's the distance that it will start pulling out of the cut before it gets to the Z minus 1 inch 2. Alright, then the third set of digits is the angle of the infeed. Each time the tool feeds in, as it takes a new pass, it will come in at an angle. Now, most of the standard threads have a 60-degree included angle, so the 30 degrees will feed in at the back side of the thread each time as it feeds in. Now you can put a 0 there, and then it will feed in right in the middle of that thread, and it comes straight in at the 90 degrees. Or you can put 29, and then it'll stay off that back thread about a degree as it feeds in each pass. Alright, the Q10 means that we're going to be taking a minimum depth of cut of 1 thousandths. Now, the machine doesn't allow decimals, so we're going to move decimals to the right 4 places. So 1, 2, 3, 4, to the right means we're going to come up with 10. And we do the same thing for the R value. That's the depth of cut of the last pass. And again, we move the decimal to the right 4 places. And so therefore we come up with R10. Alright, let's take a look at the second line of the G76 can cycle. Alright, so the second line of the G76 can cycle starts off with an X value, which is the minor diameter of the thread. Then the Z is the end point of the thread, and the P is the total depth of the thread per side, so that's radially. And because the machine doesn't allow decimals, again we move the decimal 4 places to the right to arrive at 373. Now the actual depth of the thread is 0.0373, and if you multiply that times 2 and you add that to your 0.3979 minor, then that will add up to the 0.4724 OD. Alright, so then the Q value right here is the 3/1000ths depth of cut on the first pass that we take. Again, the decimal has to be moved 4 places to the right, and that's how you come up with the 30. And we've already gone over the feed rate, which was determined by the 1.75, dividing it by 25.4, which is just converting metric to inch, and that's how we come up with the 0.0689 feed rate. Alright, so you are ready to run a metric thread. Alright, I hope this was helpful to you. If you have any questions, leave me a comment, and I thank you for watching.